So we have Gilad up next. While Gilad sets up, there's actually, I don't know, maybe 7, 8 seats here. If you guys who are standing, you want to come up, completely up to you, but I don't know, that might be more comfortable. There's 3 more over there. All right, fine, just 10.
All right. Can you hear me? Yep. I'm Gilad. I'm the chief data scientist at Betaworks. And I'm going to attempt to give a talk with a little demo. Let's see how that goes. You never know how that goes. So Betaworks is a company, it's kind of a unique company. It's structured in a way where we invest in companies. So we were one of the earliest investors in Tumblr and Kickstarter, and a whole bunch of companies across the tech scene in New York City. And we also build many companies. So you might have heard of some of these, Bitly, Chartbeat, social flow companies that were built at Betaworks and spun out as separate companies. TweetDeck was actually built at Betaworks and then sold to Twitter. Summaiz, the search engine that became Twitter Search. And we also incubate all these new projects. So some of these you might have heard of, Dots, and a really amazing game for your phone. Giphy is an animated GIF search engine, and I'll be using a whole bunch of their GIFs in this presentation. Poncho, a personalized weather app, and Tapestry, a tappable sort of storytelling medium. So there's a lot going on at Betaworks, and I'm not going to get as much into the how we work now. We can talk about that later at the Q&A if that's interesting for you guys. But in the essence, the way we work is there are a number of shared resources across Betaworks. So at the Betaworks level, we're trying to have data as a shared resource. Right? It's something that different companies can tap into. And many times when you're a tiny company, like Poncho is 1.5, they're 1.5 people, they can't really afford to have a full-time data scientist, but they come to us with problems, and then we kind of work together to figure out how to solve them. The other thing that we're trying to do is sort of solve a problem once and then reuse the solution many times. So again, you build a recommendation system for Dig Reader, then we can use a lot of the same ideas and potentially the same code to build a recommendation for Instapaper. And data streams feeding new products, right, and new features. So we use, we're trying to figure out interesting ways to use data that comes in from one product and could be a really interesting feature in another product, like highlighting what's trending across certain pieces of content, et cetera. And that's something we're experimenting with. So that's sort of high-level data at Betaworks. And what I want to talk about today is one way in which we reused a method across the different kind of data points that we have, or different companies. And it's really around graph analysis. So this is sort of the typical slide, I guess, that you get when you talk about graphs. I do a lot of work on social networks, data from social networks, and many times we represent this data using social graphs, or network graphs, sorry. So we have nodes representing users, and then edges representing the connections between them. So if we take Twitter data, for example, which will be my next example, we'll have the Twitter users as the nodes, and then who follows who as the connections. Right? It can be bidirectional, or it can be like Twitter, user A follows user B. So once we construct these graphs, actually what becomes really interesting is their structure. And that tells us a lot about the community that we're mapping, or the type of events that we're tracking, right? If we kind of build up the structure of people who participated in that event, we tend to be able to get some really interesting insight. And then the way that we look at the structure of these graphs is by running some pretty basic graph statistics. We can look at centrality measures. So between a centrality, closeness, eigenvector, degree centrality, we can start to cluster these graphs and see sort of regions of the graphs that are much more interconnected. And for that clustering, we can use a method called modularity. So let's look at this data set that I captured, which consists of 2 full days of Twitter data, where I looked at all users who have the word Python in their description, in their bio. And I assume many of you use Twitter, right? So you know how this would work. So every user that was active in a period of 2 days that had the word Python in their title, I got 4,246 users and 62,000 tweets. So now I'm going to attempt to turn back to my computer. Let's see. Let's hope this works. Perfect. So the tool that sort of is my go-to tool, I think I need to change the aspect ratio. Sorry, guys. Let's see if this would work. No. Scale. Oh, here we go. Yes. So let's try that. All right. Perfect. All right. So I'm going to show you a brief demo using an open source tool which I love called Gephi. It's a great tool to pull in graphs and do some exploratory data analysis. So the section where you're sort of trying to explore a data set, you don't want to put too much effort into it and build something for it. You can just easily use this open source tool, pull your graph into it, and run some stats to see if there's something there. I use a Python library called NetworkX where I build up a graph and then I export it into a file that's called GraphML. It looks something like this. And as you can see, there are the nodes with all the IDs, and then below you have sort of a list of edges. So it's very, very, very simple. And when you pull up the graph into Gephi, it looks something like this, where you get the square, all these nodes, all these circles represent nodes in our data, and we don't see the edges really clearly yet. If we go to sort of the data laboratory, you could see what the data actually looks like. So here's a node, jbrand is the user, like a Twitter user, their ID, and some stats that I calculated on them. So one of the things that Gephi lets you do really well is run these graph statistics. So one thing that we'll run is modularity to try to identify clusters in this graph. And we'll see it calculated pretty fast. We can see the size distribution of the modularity class that were identified. So there are a few groups that have a high membership of nodes, and then many that have like single digits, which is great. It means there's potentially some interesting signal here. The other thing that we'll do really fast is add some weighting to the graph. So I use the degree of a node. So a node that has sort of higher degree looks bigger. And let's get this out of the way. And then the other thing we'll add a color. So we're going to partition the graph by the modularity class. So we'll start to see the different sort of the different classes appear in the data. So again, you can see the different colors. It's still very messy. We can easily add labels. So here are the Twitter user names. You can kind of play with the sizes. And then we'll choose a layout, which will help us understand the structure of this graph. A layout that tends to work really well and perform well is open-ORD. So it's sort of like dangling your graph and letting gravity handle how the nodes will be situated. So it can help us sort of see the clusters that are defined by the modularity class. So let's run this and sort of see how it works. Take some time. And there we go. So now we'll just kind of expand a bit so we can see it. As you can see, it's really easy to work visually with these graphs, which is kind of nice for exploratory analyses. And we'll use something called label adjust just to be able to see this graph. All right, so super fast. And then we get this really interesting structure, right? So there's very clear structure in this data set. And there are two sort of pretty large clusters of users. And just to reiterate what this means is these are people who follow each other at much higher rates than the rest of the graph. Right? So all the people in purple follow each other much more than they follow the rest. And those tend to be, a lot of those profiles are prominent Python hackers. So actually, if we go, let's check out their Twitter profiles. Let's go to void space. You'll see, oh no, I'm not online, okay. Anyways, you'll have to believe me. And you probably recognize some of these names. The interesting thing is the orange cluster consists of Japanese users, so a lot of Pythonistas in Japan, actually, and they're much more connected to each other for obvious reasons, one language. And then there's some really interesting groups in here. For example, I think this is probably the kind of data science-y group. And let's see if I'll be able to find this. So because we don't have internet, it's not going to be as fun because we can't look these guys up. But one of the groups consists of Monty Python lovers. And of course, they have Python in their bios. And they're much more connected to each other than to the rest of the engineers. And then there's a group of actual Pythons. So the snake Python. I'll show you. I have a screenshot of that. So that was just a short demo. Let's go back to the presentation. All right. All right. Cool. Yeah. So this is the same exact graph that I sort of captured, took a screenshot, so you could see the specific clusters. The interesting thing, the Chinese cluster is much more disconnected than the Japanese cluster. So that tells us also something about this community that we're mapping. And here we see the snakes, the real snakes. And here's a close-up. So actual Python breeders, which are pretty awesome. 247 snakes. You can follow all of those. I love reptiles. Here are the Monty Python users. So it's just big Monty Python fans, which are unsurprisingly pretty connected to each other. So like you see, this is a pretty simple example of how the structure of this graph that we constructed from users tells us a lot about this specific community that we're mapping. And it's actually also a great way to get rid of spam, things that aren't related. Not that I think that Python snakes are spammy, because they're pretty awesome, but it's a way to sort of to identify them as separate from the context that we're trying to understand. So that's sort of the typical way to use network graphs with data from social networks about users and profiles and how they're connected. Another way is to construct graphs using words and their appearance together. All right, so instead of user and who follows who, word and the fact that they appear together means that there's an edge. The more times they appear together, the higher the weight for that edge in that connection. And here's a network graph showing the tags that appear on animated GIFs in our search engine called Giphy. All right, so this is across many thousands of GIFs, animated GIFs, and they're manually labeled. So we're getting these labels from actual humans. So they're really, really clean and great data. And by seeing how, by looking at these labels and co-occurrence of these labels across all our data set, we can try to get some interesting understanding of the data itself. Like, what is this data? What type of data exists in this animated GIF sort of data set? And when we dive into the center of the graph, so I used a similar technique to generate this graph and get these clusters. We get three dominant sort of clusters in this data, and I don't think it's surprising. There's the lol, right? Lots of just funny stuff. There's like kind of pretty beautiful content, like photography, just artistic stuff, and then lots of movies, lots and lots of movie GIFs. So we decided to try to see what's in the first cluster. Just what is that content? Like, what can we understand about it? And if again, you can use the same tool that I showed you. You can get rid of the rest of the content and just focus on that one cluster. And then run the same technique on it. So again, run modularity, identify sort of the different sections in that subsection. And what we got was really interesting. Within that sort of funny content, there are two distinct regions in this graph. And when it looked at this, it was like, wait, why is LOL on one side and funny on another side? They're pretty much the same, right? No. This is funny, right? Content that has the tag funny usually consists of sort of people laughing here, like funny in terms of funny. You see their face and you see them laughing. LOL tended to have, for some weird reason, have animals doing weird stuff. Or young kids doing weird stuff. But it was very clear, so once sort of we looked down into the data that represent these clusters, you could see that funny, the things that were associated with funny tend to be, people laughing. Whereas things that were associated with the tags LOL also tended to have WTF and then just be really weird kind of funny stuff. So again, this is an example of how you can use the same technique to just get a much more granular understanding of the tags that are in your system, and then generating much better recommendations from these tags. As a last example, this is sort of a more serious example using the exact same technique. This is Digreader. This is my data folder on Digreader, so all the feeds that I place under data. And again, using, if you think of a feed as the object and then the tags as the folders, we can sort of construct these graphs. And if we look at all the feeds that people placed under folders that have the word data, again, we see this pretty unique structure where we can learn that there's 3 dominant areas where people who use Digreader have their data feeds, and then one kind of smaller region. There's the data viz feed, so just different RSS feeds about data visualization. There's the data science groups. There's the sort of technical database, MySQL, Mongo stuff. And then there's a tiny cluster of data journalism feeds. So again, using the same technique, we can identify these groups and then better recommend content when somebody's setting up their Digreader or when somebody wants to add certain feeds to their reader. So that was me. You can reach me on Twitter, GILGOL, and I think we have a few minutes for Q&A. Thank you. I don't know if that's distracting.
Thanks a lot, Gilad. So yeah, we have time for maybe 1 or 2. Okay, so we talked about Giphy. What's your what are sort of the tools of the trade? What do you live in on a daily basis? Other than, what are sort of the key products you use?
I think I live in just Python. So I live in multiple screens, just running different Python code. I guess Vim, I would say, is where I live at these days. For some of the type of stuff that Hillary mentioned, where you're trying to do not the pretty graphs, but the kind of dirty, sort of not so pretty, ugly graphs that you're sending to people to explore data. I tend to use Google visualization libraries. Not to say that they're ugly. They're actually quite nice graphs, but they're pretty easy to use. And along with that, using Flask, which is a Python library that just helps make really easy APIs and endpoints. So you can use Flask to make an endpoint that hits your data, does your computation, and other people in the company can use it and see a visualization using Google Graphs. So I do a lot of that these days.
Great. Questions? If not, yep, over there.
Hey, this is Alec from Next Big Sound again. Question about the formats you use for graph storage and what technologies you use for that. Do you use like GraphML or Neo4j, or how do you store and retrieve and index that data?
Yeah, so a lot of the graphs, I use NetworkX Python library to generate the graphs. I can store the file in GraphML format or GXF. I never know how to say that format, which is much more efficient. And actually, the actual graph information can be stored either in a massive MySQL database, or I currently use Hypertable, which is just super efficient at writing content. So yeah, that's what I tend to use these days.
Cool. So maybe last question from me. So you work across a variety of different companies at Betaworks. Are you finding some big differences from company to company? I mean, I guess my question is to which extent your skill set is horizontal, and is that model of providing a central unit replicable? Could you imagine that, I don't know, Viacom, for example, would have a central data science unit that would be providing services throughout the organization?
Yeah, so it's a great question, and we're totally experimenting, and it's going really well so far. But the fact that Betaworks is quite small and the companies are flexible, I think, means that we can sort of try a lot of things out. And in terms of collaboration with the different companies, yeah, it really depends which company, because Dig, for example, is fairly large in terms of Betaworks companies. It's 15 people. I know that's small for many of you guys, but it's quite large for us versus some of the smaller ones, which are 1 or 2 people. So I think depending on the company, there are ways in which we collaborate and work together. Like with Dig, it's probably full on, like, writing things that, like, working for months on one project, where with smaller companies, it might almost be like consulting. So there's a problem, they want to know if data can help, and it might be able to help or might not. Many times we don't even have to build anything to solve that. If that could work in Viacom, like companies like Viacom, I don't know. I'd be interested to know. Maybe once Betaworks becomes the next Viacom.
You're on your way. All right, thank you very much.
Thanks.